Yeah, see, the shade's almost here. Let me just move really quick. Okay, I'm here again. Hopefully people are gonna find me. Somebody trying to message me. Oh, I didn't do the allowing rewind. I was going to turn that off. Two people are here. We're going to hope that this is going to work this time. I have no idea why it's doing this. Usually I have a really good connection, but it keeps dropping. So where I was at, for anybody that's coming back and anybody that joins later can hopefully rewind and hear this part, is that we are talking about the vascular system of plants. And those are like our circulatory system. So there are a whole bunch of little tubes, and all plants have a vascular system. If they didn't have a vascular system, they wouldn't be able to basically move things around, right? They have to have some sort of set of tubes in their structure. But the thing that makes the plants that give us good fibers, the thing that makes them unique, because even though all plants have vascular systems, not all plants give us fibers. There's only like a pretty rare number of really, really high quality fiber bearing plants, we call them. So those are the ones, the way I like to think about it is that those are the ones that decide for some reason, whatever it's because of what they've got around them, it's how or whatever they choose to do. They're the ones that have decided to build. Hey Benjamin, hey Ben and Kimberly. Kimberly's there too. Hi. So the ones that are the fiber bearing plants have decided to build their vascular system out of something that's strong, out of some material through some structure that is an extractable fiber. So most plants' vascular systems, especially once the plant's dried out, they're just brittle, they just break, they're somewhat strong, whatever, they're a bunch of different grades. But the ones that are the high quality fibers are the ones that have built it out of a strong material. And there tends to be certain families that have more fiber bearing qualities because that's sort of it's the structure that they're doing. And there's similarities in there. The other big thing to remember in doing this is that the vascular systems of plants are very different depending on what kind of plant it is, like I said. And the main big grouping that divides the two worlds, I like to call it, in this plant kingdom, basically, is the difference between what are called monocotyledon plants and dicotyledon plants. So if anybody is remembering their botany when they were younger, this is going to be pulling back on maybe some old memories, or maybe this is the first time you've heard of this. But the monocotyledon plants have to do with how many cotyledons are in the seed. So they're the monocots, is the short name for it. And they're the oldest plants. So they're the ones that were around a long, long, long time ago. They're more ancient. And what happened is they split and started making two cotyledons and became dicotyledon plants. And those are the more recent plants. But dicotyledons are still really ancient, but they're not as ancient as the monocot plants in their lineages. So The monocot plants are things that we know as grasses, as corn is an example of monocot. Um, Palm trees are monocot plants. So they're the ones that tend to not have a trunk and branches. They don't have bark. They don't have an inner bark and an outer bark. They tend to be mostly leaf and then a flower stalk of some sort that goes up in the middle. And so for that reason, their structure is almost completely is all in their leaf. And it's a whole bunch of long, skinny tubes that run down the entire length of their leaf. So they're long blade leaf plants. Yuccas, agaves, irises, and palm trees are the main ones that give us fibers that we talk about, as well as New Zealand flax, which I'll go into later. So those are the long leaf plants that are the ones that give us those fibers out of their leaves, and those are the monocot plants. The dicotyledon plants are the ones that have trunks, that have an inner bark and outer bark. They tend to grow up and then they'll have flowers, but they don't necessarily have a stalk. They don't have a basal leaf structure. So they form their fibers, their structure, the main core of their structure is their actual stem or their trunk. And so for that reason, their vascular system is the inner bark layer of their bark. And it's a whole bunch of tubes that run up that are sort of usually more mesh structured, and they're running in the inner bark of that stem or that plant or that tree. Within that monocot, or within that dicotyledon world, we have what are called stem fibers, which are plants that only grow for 1 year. And then we have what are called bark or trunk or tree bast fibers. And so the bast is the other name for inner bark. It's a bast fiber is the thing that's in the inner bark. And if it's a monocot plant, it's a leaf fiber or a hard fiber. And the ones that are in the bark, in the inner bark of the trees or the stems, are called bast fibers, B-A-S-T. And they are also called soft fibers because they have a softer structure to them. But then, like I said, there's the ones that are in the stems that only grow for 1 year. And then there's the ones that are in trees that grow for many, many years. And those are called the tree bark the tree bast fibers. So those are the three main classifications. We've got leaf fibers, we've got stem bast fibers, 1 year's growth, and then we've got tree bast fibers, which are several years' growths. Within those three groupings, there's also a lot of different ways to process them because they're so different in the way that they grow, and they're so different in the way that you get to them in the first place and in their structure. Then you approach the way that you process those fibers really differently. So it looks like people are arriving again. It's at 11, and I've already, for anybody that's arriving now, I've already talked, and when this is over, you can rewind. And I tried to start this discussion right where the other one dropped off. Hopefully this one is not going to drop off again. I'm not sure what's going on. My connection should be fine, but it just keeps dropping. So when the different techniques that we're looking at in getting these things, like I said, are defined by what kind of grouping they're in. And also when we harvest them is defined by what kind of grouping they're in. So with the leaf fibers, the hard fibers, the monocot fibers, the ones that are the long leaf plants, they almost completely, I don't really know of any exception to this, are extracted when the plant is green. And the reason for this is that because the entire leaf, and this is a really good example of an agave leaf, because the entire leaf is full of these long, you can see these long monofilament fibers going down. They're just extracted right there at the end, but those guys go all the way down the entire length of this leaf from the base to the tip. And there's hundreds of them in here. The entire thickness of this leaf is full of fiber. And around that fiber is a whole bunch of everything else that the plant grows with. It's a bunch of paste, it's a bunch of snot, it's a bunch of like plant material that's full of glues and tight and everything. And so if you were to harvest, like this is a dried out agave leaf, and this would be really hard for me to extract the fibers. In a pinch I could make it happen, but literally the fibers have been glued to each other by the action of that plant drying out. So that's why with the agave leaves and with these leaf fibers, you process them when they're green. You don't want to wait for them to dry out. So once you've cut the leaf from the plant, you have to then really quickly make sure you process everything before it dries out. So it's done in the green state. It can be a hard thing, and that means that you have to focus a lot of energy sometimes, but you just know. But the cool thing about it is that these guys pretty much grow all year. There isn't a season for harvesting so much. There may be some variations through the year, but pretty much you can walk up to an agave plant, you can walk up to a yucca plant, you can walk up to a New Zealand flax plant, And any time of year, you can cut the leaf off and do your processing that I'm going to talk about in a second, and have your fiber, and it's not so dependent on the time of year like so many other of the plants are. So you harvest them green is the main thing. And then you also have to then get all of those glues that are holding that leaf together. You have to make that go away in some fashion. Sometimes you can take the whole leaf and you can just pound it with a mallet, and you can do that with agave leaf, or you can do that with yucca leaves, and you can do that with New Zealand flax leaves. Here's an example of some New Zealand flax that's all folded up, but this is a New Zealand dried out New Zealand flax leaf. And then here's some dried out yucca leaves. So I wouldn't be processing them in this state. These are just for samples. But when these were green, I could just take a wooden mallet and put it on a round of wood, and I could just pound the leaf, single leaves at a time, until all of the glues have been sort of broken up. And then I could wash it a bunch, and I could get the fibers out of there. You would never want to do that with agave, because agave, the pulp that's in the agave plant is it's got a sort of a caustic burning effect on most people, and it causes a really, really painful rash anywhere that the juice from the agave hits your skin. And I know several people who tried to play with agave and didn't realize this. As people are coming on, if anybody has a question, please let them, put it in the comments, and my friend Sarah Beth will pass the question on to me. This is like I said, the agave, you don't want to be doing it fresh, because when that stuff hits your skin, it will cause a really, really painful rash. So my preferred way of processing the hard fibers is actually a very traditional way that has been used all around the world, I'm sure, but it's called pit baking, because you want to bake or steam these green leaves as much as you possibly can, and that just makes all of that sort of mucilaginous stuff and the structure of the leaf just turns into a paste, and then it just washes off or scrapes off the fiber really, really clean and easily. So you take, generally it's a heavy energy input. So it's the kind of thing where you do, like 10 agave leaves at one time, and maybe 50 yucca leaves, and you put them in the pit, and you're doing this huge thing, and you've got to process it all out. But then you've got enough fiber that's going to last you for the entire year. So generally, when you're doing a pit baking or steaming, you don't just do a small amount. You can just steam them. You can try to get them into a pot and steam them, but the pit baking is the way that I've really enjoyed doing it. And in the slideshow, there'll be some really good pictures of the pit baking. But it's just like how you would cook food. You dig a pit in the ground, you line it with rocks, you put in a bunch of green materials and moisture, and then you lay in all your leaves. You put more green materials on top of it so that everything steams really well. Then you cover it over with a mat or some sort of thing to protect it, and then you put the dirt back on top, and you put a fire on top of it, and you burn that fire for 4 or 5 hours, and then you let the fire go out, you dig it out, and it steams as you're digging it out, just like you've been cooking food. And when you're done, you'll have these cooked leaves that all the fiber just easily separates from all of that pulp and all of the leaf structure, and it's really, really nice and easy to process. So that's my favorite way of doing the hard fibers. And it's essential with the agave, and it's easier with the yuccas, and it's easier with the New Zealand flax as well. However, traditionally in the old days, with New Zealand flax, if you're looking up at any New Zealand flax, is called New Zealand flax because it comes from New Zealand. So it is the fiber that has been used by Maori people, the indigenous people of New Zealand, for forever. And they have, in New Zealand, they have many hundreds of varieties of flax, and a lot of it is used for basketry. And this sample has gotten a little tangled, unfortunately. Here's one that's not. But there's only a few varieties that I've been told. A friend of mine who's Maori, who I met at Spirit Weavers, gave me this sample.
Sean Woods wants to know, are there other leaf-like plants for cordage in the Pacific Northwest besides agave?
Okay, yeah, I will answer that in 1 second. So this is an example of the New Zealand flax that was already processed, that was given to me, that came from New Zealand, from a Maori weaver. And this is the one that it's actually just like flax. It's so fine and so wonderful. And what I've been told is basically that they don't let these ones leave. It's not something that you can go buy at the store. It's not something that you can get very easily. You pretty much have to be in New Zealand to be able to find it, because it's sort of being like it's a heritage that's being protected. So New Zealand flax is Phormium 10X. It's commonly grown all over the place. It's a really great, here in California, Northern California, it's a really great ornamental. People grow it all over the place. But the one that we are getting over here, that we're growing, is for beauty. It's sort of like it's got different colors in the leaves. They're really beautiful plants, but they aren't the ones that have the fine fibers. You can still make fiber out of them. And I don't know if you can see this on right here. This is one of the ones from the local ones that we just find all over the place. It's a nice New Zealand flax, and it'd be great for basketry. But if you can compare the quality of the fiber that's right here, I don't know if the camera's showing it, with this, you can see how much finer the fiber that's the true fiber one is compared to this one. So I can extract the fiber out of this one. It's just a little bit coarser. It will work, but it's not the true New Zealand flax that Maori people have been using for thousands of years. So, but you know, with any of these, it's also the truth. The agaves, there's tons of kinds of agaves. This is one of the big century plants, and these fibers are actually fairly coarse. If you get into the other agaves that were the one when you buy sisal, people don't realize this, when you buy sisal twine at the hardware store, it's agave fiber. It's agave cisalina, and there's a whole bunch of different of those agaves that are grown all over the place. But the ones that are for sisal are much finer than the big century plant. So this one actually has a fairly coarse fiber where if you're really going for good fiber, you'd be going for different varieties. The question about ones that grow in the Northwest coast.
Are there other leaf-like plants for cordage in the Pacific Northwest besides agave?
You know, the agave does not grow up there. That's a desert plant. I'm going to run off for 1 second and give you one that grows a little ways. It's a plastic Ziploc bag. It was right in that area just a minute ago. It must have gotten moved. Sorry about that. I have a plastic bag that it's a Ziploc bag, and it's got some fibers in it of the wild iris, which is our local here in Northern California and Southern Oregon, our local hard fiber. And it's different than the other ones. I'm going to look for it in a little bit and try to do the processing later, but these are the dead dried leaves, but again, you usually harvest them green. And this is the fibers that come out of them. And as far as I know, this is really the only hard fiber that's really, really commonly found anywhere in Northern California and Southern Oregon. And I don't think it goes, thank you. I don't think it goes that far north. I think by the time you're into Central Oregon, like going from north to south, you start to run it. But these are the leaves of the wild iris, which is our local hard fiber here in Northern California, like I said, and Southern Oregon. See how the tips are searing? I just picked these out of my yard just this morning, and they're wilting. And when we get to processing, I'll show you how I extract the fibers from these. But they are a very unique fiber in that there's only 2 fibers in each leaf. They don't they're not completely full of the fibers like New Zealand flaxes and like agave and like yuccas are. I don't really know of any other hard fibers. The only other ones that would be common if there were some cold hardy palms. So palm trees are also hard fibers, and so the entire leaves of some of the palms are strong enough to not necessarily extract really good fiber, but to use as a cordage, as pieces of the fiber. So you can look around, and you know, the hard fibers tend to be sort of warmer climates, it seems like. So as you go up into the north, you don't find it as much. There's a whole bunch of other domestic plants that people have used and that are used all around the world, but the majority of the fibers that you find are the much larger grouping are the soft fibers or the bast fibers. So I'm going to come back to the hard fibers unless there's another question about it. But New Zealand flax, like I said, is a domesticated one that we can find, and we cannot find it in the highest quality fibers like the ones that you get in New Zealand, but it still is one worth playing with, and you can still make a decent cord out of it. The quality of the true New Zealand flax is like exceptional. It's like one of the best fibers in the world, and that's why it's called New Zealand flax, because flax is one of the best fibers in the world. But it's one of those funny things is that common names don't really show the relationship between the fibers, because flax is not a hard fiber. True flax, which I'm going to get to in a minute, which is what linen is a soft fiber. But in New Zealand, their New Zealand flax, their hard fiber that's from the stem of from the leaf of Phormium, is so fine that it was compared to true flax, and that's why it's called New Zealand flax. So I'm going to move on to the, if anybody has any questions, let me know. So I'm going to move on to the soft fibers now. So the soft fibers, they're broken into, like I said, the stem bast fibers. The bast fibers are the soft fibers, and the tree bark bast fibers. The strongest tend to be the ones that are from the stems. And that's sort of where the majority of things come from. And that's the ones that most of us end up processing. But I'm going to not get to them yet because the bark bast fibers, the ones from the tree barks, are sort of more similar in processing to the way that you do the hard fibers. So I'm going to go with them because they're somewhat similar, and then I'm going to move into the stem bast fibers last because that's what we're actually going to be processing, and they're processed very differently. So the tree bark fibers, again, they're in a structure that's growing for multiple years. And what you do when you're trying to extract the tree bark fibers is you basically need to take a piece of bark off of the tree. And for that reason, just like with the leaf fibers, you want to do it green, you want to do it fresh because everything is glued together. There's a lot of other stuff in there that has to be removed. It's a big, thick thing. And if you try to do it in a dried out state, it's just going to drive you crazy. The glues, like everything's glued together, they're not going to process right. And so what you have to do is go up to a live tree when the sap is running, when the bark is easily removed, and you take a section or all of the bark off of a trunk of the tree or of a branch of the tree. And obviously one of the things that we have to do when we're thinking about this is that we need to make the choice of whether we're killing the tree or we're wanting the tree to stay alive. Because if you remove all the bark or the majority of bark from a tree, especially a ring of bark from the tree all the way around, anything above that point is going to be dead or dying because we have severed basically the vascular system of that plant. You've cut through all of those tubes and the plant can no longer send anything above that point that you've cut the bark from. So you want to be making a choice. And so generally when you're harvesting the bark from a tree, you're looking for something that fell down, like a trunk that fell somewhere. Or if you're harvesting something for something already, like if you're making a boat and you're going to be cutting down a tree, then you would then take the time to process all of that bark into a large amount of fiber because you wouldn't want that bark to be going to waste. Or if you're cutting down a limb of a tree that is fiber bearing because you're looking to make a bow, for example, then you would use all the bark that you were stripping off of that tree. Or if you're cutting down a maple tree or you found a maple branch or something because you need to make a tanning beam out of the maple, you would then extract the fiber out of the maple bark. So it's the kind of thing where you're making a choice and you're either pruning or actually killing a tree in order to get to the bark. Or you're lucky enough that you found a tree that came down that's still green enough, that's still wet enough that you're able to get the bark off so that you can extract the fiber, if that makes sense to people. So the one that's the most well known of the bark of the tree barks is a basswood if you're on the East Coast. And here's a sample of basswood bark. Got it upside down there, but there's an example of basswood. And this is the bark side, the outer bark. And then in here next to it is the inner bark, because you split the two from each other. And then this is the processed fiber right here. Another one that is really, really well known is red cedar. And this is in the Northwest. This is like a dominant fiber that's used for almost everything in the wet environment of the Northwest coast. It's so wet that a lot of things, especially skin-based things, don't work. And so they don't, tanning and skin-based things are not as common, where red cedar lasts in the environment. And so tons of stuff is made out of red cedar. And if anybody wants to learn more about this, I highly recommend the book called Cedar, that I will put a link in the comments after this. But there's a lot of documentation on how to process cedar, so I'm not going to go into it very much, but get the book by Hilary Stewart, I think it's called, and get that book, Cedar, for all the specifics about processing cedar. I personally don't live in the Northwest coast where red cedar happens, and so I don't have a ton of experience with it, but I just have a few samples and I've worked with it a little bit. The tree bark fiber that's really the dominant thing in my area that I end up using a lot, that's my favorite, is Fremontodendron californica. And this is a really, really wonderful plant. It doesn't actually grow it's not a native right in my zone, but people grow it ornamentally all the time. It's also called flannel bush. It has a really showy yellow flower on it, and so it's something, and it's very drought tolerant. So people like to grow it in their gardens, but it's on the other side of the state where I am in the Sierras is where it grows like crazy. So it's something that's a really common plant in certain areas. And it has a really, really nice fiber spark. It also, the wood can be used to make sort of a quasi powerful bow, so that, you know, if you're trying to harvest it to make a bow, you then can harvest the fibers. And it also grows in a very layered habitat, so you're not having to kill the whole plant. You can just go in and cut off a branch and use the bark from a single long branch, and one branch will give you a lot of bark. So you can go in and actually prune the tree. And if you're growing it in your garden or you're growing it in your landscaping, then you can just prune off a couple branches and get a lot of fiber out of it. So when we're talking about we're taking a whole tree or we're taking the branch, then, and you always, like, I haven't gone into this, is that you want to do this in a sustainable fashion. So with the leaves that I was talking about earlier, you only take a few from each plant. You never want to over harvest it. And with the branches and with the trees, obviously, you don't want to kill trees if you don't have to, and you want to just be really make sure that you're taking a tree out of one where there's a lot of trees. There's sustainability issues that we want to work with here. You always have to be aware of what you're doing. So very often pruning off a branch out of a tree would be preferable to taking the whole tree. Where there is another fiber that is used too in my area, which is redwood bark. And the same thing, a big redwood tree, you wouldn't want to be cutting it down for the most part. But in the old days with cedar and with redwood, if somebody just needed a little bit of fiber, they would go up to a large tree and just make a cut, maybe, like 6 or 8 inches wide. And they would cut into it through the outer bark into the inner bark. And then you could grab the whole thing and pull on it, and you could run a really large piece of fiber all the way up the tree or part way up the tree until it ran out and fell down. And then that would give you enough fiber to use. That's what people used to do in the old days, but it's not really a recommended thing to do now because it does scar the tree. So, you want to be sort of figuring out where you're going to be harvesting from and how you're going to be impacting. But it is a way, and it doesn't kill the tree because you haven't cut the tubes all the way around. You haven't done what's called a ringing the tree. So if you're just taking a small piece, then the tree is able to heal over it and continue growing. And you can find scars on old trees where that's happened in the past. But like I said, nowadays with large cedars and with large redwoods, that's not really a recommended practice, but it is something that people used to do in the old days. So since you're taking it from a growing tree, it's easiest to extract, to remove the bark from the wood when the sap is up, when it's growing, when it's actively got water and juice running into it. That's when you can remove the bark from anything. And so that's the preferred time to take it off of the tree. And like I've said, you remove it, you peel it off, and then you have to do this thing called splitting, which is you need to break off the outer bark from the inner bark. And a good thing to imagine this, and this is my sample of this right here, this is the piece of the Fremontia. This is the outer bark, and this is the inner bark that has been split out. And you do it with a motion that's like this, that you're pulling on the two sides evenly. That's very, very much like how you would split willow or how you would split something. You're evenly dividing the two. Because if you think about it, the outer bark is not where the fiber structure is. The outer bark is a protective layer. And the inner bark, which is the part that's the closest to the wood, is where the fibers have happened. But since it's coming from a tree and it's been that fiber that you're extracting on the inside could be, most likely like 10 years worth of fibers. And this is the part that makes me understand what I'm trying to extract here, is that when a tree grows, it's a small, tiny little thing at the beginning. It grows, and this layer that we're taking out, the inner bark that I'm talking about, is actually the cambium layer of the tree. So people hear about the cambium. If you go back to your botany when you were a child, it's these two things that you may not remember, but you might remember, that are called xylem and phloem. So there's 2 layers to the cambium layer, and one of them goes onto the wood after it grows. There's a year of growth happening. There's a lot of energy happening. And then one of them moves into the trunk and turns into a growth ring of wood. Like if you look at the growth rings of a tree, and people know about that growth rings happen in the tree, but they also don't think about that growth rings happen in the bark as well. And so one side goes onto the bark side, and that's the layer that we're extracting in order to make fiber out of it. And so usually, and then as the tree ages, you know, those layers are going to go more and more towards the outside. So when it's sort of hard to think about, but if you walk up to a redwood tree that's several thousand years old, and you're looking at the outside of the redwood tree and can see those fibers on the outside, and you might even be able to pull a few off and twist them up. They're pretty strong, but then they would break a little bit. You got to realize that those fibers could be 1,000 years old, because those were the fibers, the ones on the outside of the tree were the ones that were formed when the inside of the tree was being formed, when it was just a tiny little, like small little tree. And so it's the opposite. It's sort of like an inversion of the way the fibers are getting formed. And so with all the trees, they do that. Redwoods do it to a great degree. So when you're splitting off a redwood, if you get a piece of redwood bark and it's the entire thing, it might be this thick. The part that you're splitting off that you're going to be extracting fiber from will be this thick. So just a tiny little bit, the last maybe 10 years of growth rings that are going to be used in the fiber, because the other stuff is all the protective outer layer that's gotten really old. So you have to crack off anything that's the brittle outer layer, and you leave just it sort of separates on its own, and you find the place that is the thickness of the layers that you're going to extract. So after you've done that, you're left with a hank of just the inner layer. You extract, you discard the outer layer. And so this is my example of the inner layer. And this is a piece of Fremontia again. So this is the inner layer right there. I'm trying to make it so you can see. And then this one right here is the outer layer. And so I'm going to discard the outer layer, and then this inner layer is fibrous and strong, but it's glued into a sheet, right? Because again, just like the hard leaf fibers, it's glued by all the lignins and everything, all the mucilage, everything that's in that plant. And so we have to figure out how to extract those fibers from everything else that's around it, unglue it, liberate the fibers. And the way that that's usually done with the fibers of the trunks of trees, of the inner bark, is that you do a retting process. So you soak it in water, and that makes those lignins breaks down all of those glues. And then after, you know, a week or two of soaking and changing the water and doing all that, you pull it out, and the fiber is all released, and it's gone from this stiff woody thing right here that you can hear the noises on that. After you've washed it, it's turned into this. And one of the things that you can see with this is you can see very often the tree barks, especially Fremontia, and basswood has the same thing, and so does how bark, which is the one that's from Hawaii that's very similar. Is, do you see that structure? It's like a net structure within the fiber itself. So it's almost sort of, see how it sort of looks like a net? That's the structure that all of these tree barks have in common. And so if you see a bark structure like that, you might think like, oh, this might be a fiber bearing bark. So the retting that I was just talking about is also something you can do with the leaf fibers that I talked about earlier. The reason I didn't mention it at the beginning is that I tend to not like try to do it, because especially with agaves, I never ret agaves, because in order to ret a plant this big, it gets really putrid and really disgusting. So I pretty much avoid it whenever possible. When you're talking about New Zealand flax, or when you're talking about agave or yuccas, it might be that you could ret them without it getting too disgusting. But again, I almost prefer to take those and pound them green if I'm only trying to process a few. So I pretty much really like to either bake, like steam bake, or pound green when I'm talking about hard fibers. But with the bark fibers, with the tree bark fibers, you pretty much have to ret them. And it's something that you just have to do. Retting, you want to have clear water, you want to have good water, you want to change the water periodically. But you also want to remember that the retting process takes the oxygen out of the water, so you can't expect to then water plants with that water. You want to pour it on the ground, but the plants aren't going to be able to get any benefit from it because there's not any oxygen left in that water. And it's something that be really important is if you're retting a bunch of materials in a small body of water that has any other life in it, like any fish or anything, you could steal the water from that body of water, and the fish in that pond could die. So you want to be careful about where you're doing a lot of retting. And that was a big problem in Europe in early industrial times, of people retting flax and retting nettles, but especially flax, in streams, and destroying like the life in the stream because they were stealing too much water or too much oxygen from the water. So it's just something, you know, I like to ret in tubs, not in live bodies of water. You can do it to a small degree in a large pond, that's fine. But if the number of plants that you're retting gets too big, you might kill the fish in the pond. So just be aware of that. So Retting is an art form. It's something on learning how to time everything. You just check things. You make sure you wash your hands a lot because it can get really stinky. But it is something that is a super powerful mechanism that we depend on in order to extract fibers, especially the tree bark fibers, but also for certain ones of the stem bast fibers, we still use retting for as well. So I'm going to move on to the stem bast fibers because we're already at 2 o'clock. We're halfway through this. So the stem bast fibers are different than the tree. So you have to envision, instead of envisioning that a tree has grown many, many years and you're trying to extract that inner bark layer from the inside of the bark, a stem bast fiber is just 1 year's growth. And so it makes that year's growth. It makes a year of wood growth. It makes a year of inner fiber growth and 1 year of outer layer. So there's just a little bit. And so it's pretty small. It's just a single year's growth. And behind me here, I have a stem of dogbane, which is a really good example of a year's growth for a dogbane. And these are bundled right here. This is a bundle of a bunch of showy milkweed stems. So each one of those is a year's growth that's been harvested. And then I have a couple other samples back here too, which are showing the difference in the sizes. This one is a whole bunch of stems of narrow-leaved milkweed, which is it's a much more slender stem. And then this one here is a whole bunch of stems of true flax, of Linden usitatissimum is the Latin name, and this one's got the roots attached to it. So you can see that flax is really long and skinny, so you have to go through a lot of sticks of flax in order to get the fiber out of it. And on the other extreme, back here, I have a really cool sample, and these are folded up, so these are actually, as long as these guys look right here, these guys are 3 times as long as this when they're growing. And this is a really cool plant that you don't normally find. I was given this at a botanical gardens in Berkeley where they're growing it, but this is an Asian plant called Rami. And it's one that you hear about. It's a really, really amazing fine fiber. And it actually is an urtica. So it's a huge nettle, essentially. And like I said, these guys are 15 to 20 feet long and they're huge. And the fiber in them is really nice. And so those are all examples of stem bast fibers. So even though the Rami is huge, it still does that in 1 year. The plant just goes crazy and grows up really, really far. So how the stem bast fibers, and if you have any questions, please go ahead and put them in the comments. How the stem bast fibers are extracted depends on which ones, because obviously the difference between the Rami stick, or even the difference between a dogbane stick and the flax stems, but this is domestic flax, but the wild flax is also very, very similar and really thin and small, is that, this we can extract by hand by scraping, but if we were to scrape every single one of these tiny little sticks, that would be incredibly tedious. And so the flax tends to be sort of processed in a different fashion, using a little bit more mechanisms instead of individually working with it. But right now, what I'm going to do is I'm going to show you how to extract a dogbane stem, and that sort of can be applied to a lot of other ones. Another one that I didn't mention is, I mentioned the Rami as being a big nettle, but then we also just have true nettle too, is a stem bast fiber. So in general, the time of year, the season, so I mentioned that for the tree barks, the season has to be in the spring into midsummer when it's actively growing. Once it starts slowing down and it's not actively growing, it's harder to remove the bark from the trunk of the tree. So there's a season to that. With the leaf fibers, with the hard fibers, for the most part, it's pretty much all year round, except for the iris leaves, which I'm going to show extracting in just a minute. These guys, the green iris leaves, which are in this bag so they stay moist, right now is when the season starts. So you let it grow through the you let it grow, and then you're waiting until the leaves sear. And for the most part, that's sort of one thing that you have to do, is you have to let things develop. So fibers are the structure of the plant. And if it's just brand new growth early in the spring, you can try to extract it, but there's not any time for the fiber to have developed. So in general, you're waiting for the things to get all the way through their growth cycle, at least their growing part, till they're They don't have to be flowering. They don't have to go through their flowering cycle, but you want them to at least gone through their growing cycle to the point of flowering. And on the wild iris, the point that we know that we can start harvesting it is when the tips sear. So this was a green plant until it just started getting really hot a couple weeks ago, and now I'm starting to see the tips searing. So now I know that the season to harvest these iris fibers is at hand. It's about the same time as the season for harvesting the bark fibers has ended. So the bark fibers, I'm not having to wait because it's many, many years of growth. So as soon as they start growing in the spring, as soon as the bark is removable from the tree, we're in that moment of the season for doing them. So the last like 2 or 3 months were the perfect time. But now we're getting to the height of summer. It's getting hotter. The trees are slowing down their growth. So as long as it's still coming off the wood, you could still do it, but it's going to start gluing down to the wood, and we're going to be out of the season for doing the bark fibers very soon. We're right in the transition depending on where you are. The season for doing the stem bast fibers, again, is just like the iris fibers, is we can't do it too early because they don't have a chance, because this is 1 year's growth. They don't have a chance to develop. If you try to harvest them at all early, they're not going to have any strength to them or any kind of integrity. But we do also, and we can, usually what I do with the dogbane is you can just let it go all the way dead and dormant. You can let it completely die down. When you do that, you get a coarser fiber. It could theoretically be stronger, possibly. And for certain plants, it's preferable. One of the reasons that I tend to do that with dogbane is that dogbane has a toxic sap to it. It's a milky latex sap that's got a pretty heavy action on your heart. It's a digitalis-like heart stimulant. So it's a little bit edgy, it's a little bit iffy to be working with it in the green state. If you ever do work with dogbane in the green state, you got to make sure you wash your hands. You want to make sure that you don't ingest it in any way because it could make you really sick. So in general, most people that I know wait for the dogbane to go totally dead and dormant. Just because it's easy, you go to the patch, you know, it's what you can do. But with all of the stem bast fibers, there's a quality change with the fibers that happens. So with flax, if you ever look at flax culture, which is, there's a ton of literature on it, you want the people, for the finest fiber that people are spinning into the finest fabrics, they actually harvest like right before it flowers is the finest, most silky of the fiber. And then it changes color and texture and gets coarser and coarser as it goes beyond that point into being totally dead and dormant. And so people choose when to harvest the fiber depending on that. And that quality change is also true for dogbane, and is also true for milkweeds, and is also true for nettles. But we're just not necessarily taking it to that cloth stage. So most of the people that I know that work with these guys don't tend to worry about it and just harvest when it's dead and dormant. But it is something that I've been wanting to experiment more of, harvesting a little bit earlier with some of these plants and getting a finer fiber out of it. That said, dogbane fiber is one of the best, and it's got an amazing quality of fiber in general in it, and so it's definitely something that I really like to utilize. This is backwards, it's really confusing. So this one, so this is a stem, it grew from the ground here. So if I am waiting for it to go dead and dormant, I go into the patch, and with the dogbane and with the milkweeds, they are pretty much, well, with dogbane, the dogbane is a perennial plant. And so when you're going in and you're waiting for it to have gone dead and dormant, and the milkweeds are the same, they're going to grow back the next year, and they're going to grow up, and nettles are the same way, they're going to grow up. So you're not having to so much worry for sustainably harvesting them about taking something that's going to keep the plant alive, because when it's dead and dormant, it's already done its growth, it's stored its energy, and then it's going to send up new growth. So as long as you don't disturb the roots, you can harvest a lot of them. And these guys grow in dense patches. You don't find them everywhere, but when you find them, there tends to be a lot of energy here. And I'm going to try to do an experiment. Can we put this over the keyboard here real quick? And like I said, if you have a question, please put them in the comments. And Sarah Beth is going to try to do it, and she's going to tell me if I'm doing this, because I want you to see this so that you can see what's happening. So this is my way of trying to do this. A little bit up. Okay, yeah. So is that in focus? Hopefully everybody can see this. So I harvested this stem dead and dormant. And then I dried it in the sun because it had some moisture on it just from our moist winters. And now it's been stored for since last fall. And now I can come in and just process one stick at a time. So this is the base of the stick. I have a sharp knife, and I come in and there's leaf nodes right here, and there's leaf nodes right here. And if you have one of these at home, you can start doing this with us if you want. But I put the knife down and I scrape, and all I'm doing is taking off a little layer of the outer bark. And it's a sort of a steady scrape. I'm keeping the knife at a 90-degree angles, and hopefully this is in focus and people can see what's going on. This should be the way that you would be seeing it happen because I'm reaching around my computer. But I'm scraping, I'm scraping, I'm scraping, and I'm just taking off that nice little outer bark layer. I'm trying to do it consistently. I didn't go too deep. This is about how deep I want to go, but I'm going to show you just so you know, if I had gone too deep, you see how if I just was being really rough, how I would be picking up all those fibers? And I'm destroying them if I do that basically. So you don't want to be seeing fibers get picked up. Then I turn the stick over, and I usually lay this on my knee. And then I scrape from leaf node to leaf node up, going from the base to the tip of the stem. So I'm scraping again, I'm picking it up, and I'm just doing a light scrape. It's a little awkward because I don't have it on my knee, I'm holding it in the air. But see how I'm just overlapping my scrapes? I'm just scraping down, and I'm only picking off that fine, fine outer layer of the stick. You know, I went a little deep there, so then I'm going to go up to the next one, and I'm not trying to go too deep. I'm not sliding the knife. It's just a slight color change. It's basically taking off that skin that's gluing the fibers in. I'm going to do one more, and then I'm going to come off and show you so you can see my form when I'm actually doing it. But I'm just trying to show you the depth to which you're trying to scrape, which is not very deep, if you can see that. I'm going to come around here now. I don't see the comments scrolling. Okay, we might need to. I'm going to make sure that the comments are not. Yeah, there they are. Okay, sorry, the comments were getting hidden from us. I'm going to pull forward here and see if I can show you the form that we're doing this in. Okay, so I'm going to try to get this up so we can see it. So when I'm doing this, and if Sarah Beth is reading the comments now. So I put it on my knee, is my favorite way of doing this. And I'm at this point right here, and I stabilize it on my knee, and then I just scrape, and I just go once over, and I try to scrape to the depth I want it in one stroke. So I'm going around, I'm just taking off and letting that powder fall. And then I can come back to the next one, and I'm just scraping again. And I'm just going leaf node to leaf node pretty much. It's a steady scrape. I'm overlapping my scrapes, and I don't have to get every little bit off. I'm just trying to take the bulk of it off because it's like a glue. It's like a sort of a cellophane layer that's holding on a gluey layer that's holding the fibers together on the inside. And it is possible to extract stem bast fibers without taking the bark off. That's something that I'm going to show you later. But for dogbane and for anything with a smooth bark, this is my preferred method. I really like to scrape first because I feel like it's much less tedious than cleaning the outer bark off later. But if you don't have a sharp edge, if you need fiber there, you can do this without a sharp cutting edge. But right now I'm scraping all the way up, and I'm scraping all the way to the tip. And so the Latin name of dogbane is Apocynon cannabinum, meaning fiber-bearing dogbane. There are other dogbanes that are shorter, that are not the fiber-bearing ones. The other name that's used is Indian hemp, and the reason for that is that when people came here from Europe, they encountered the tribes on the East Coast making everything out of dogbane. And so they said, oh, and the people coming from Europe were using true hemp, cannabis, as their fiber for everything that they were using over there. And so they said, oh, this is just like our hemp. So it's Indian hemp. It has nothing to do with coming from India. It has to do with being Native American. So it's a reference to Native American people when it's called Indian hemp. And the term hemp basically means that it's fiber bearing. It comes from cannabis. So, and that's why the word cannabinum is in the name of this plant, because it means fiber bearing. So this is the scrape stick, and you can see I'm trying to get with the computer here. You can see that it's got this hollow thing right here. And I'm going to come around here again and try to do this backwards thing to show you the cracking, because I think it's going to make it easier for you to be able to see it. So I'm holding the stick up. It's got a hollow tube in it. So what I do is I just squeeze it. And then I move my hands up, and I squeeze it again, and I slide my hands up, and I squeeze it again, and I squeeze it again, and I squeeze it again. And if you're coming along, if you're trying this at home, you're welcome to try this. And I'm just squeezing, I'm not breaking, I'm just cracking. And I'm moving it down, I'm moving it down, I'm moving it down. And then I come back again and I squeeze this way already. And so if I rotate 45 degrees, like exactly opposite, and I squeeze again, it's going to break it into 4 pieces. And it's going to finish the break and cleanly move it all the way up. So I move my hands up, all the way up, all the way up, until I get to, I have my cracked stick. And then I come to the middle of the stick, and I put my fingers in there, and Dogbane doesn't give you splinters, so that's a nice thing. If you're doing this with nettles, be very careful because you'll get splinters from the wood at this point. But I slide my hand there, and I'm dividing the fibers, and I'm dividing the stick in half all the way down to the end. And then I come down here, and I divide it to the end that way. So that gives me 2 halves of my fiber. And when I'm doing this, usually I actually roll it out and I keep all 4 together. But if this is your first time, we're just going to do 2. So you want to do that splitting in half like I did. I'm going to come back around now again. So the way that I like to do the cracking is I am holding this. This is the pithy side of the, is that good? This is the pithy side of the stick, and this is the bark side of the fibrous side of the stick. So this is the inside, this is the outside. So I hold the outside in my right hand, and you see how I keep it like 2 or 3 inches in front of this knuckle, like this finger of my pointer finger, and then my thumb goes right on top of my pointer finger. And what that allows me to do is hit the wood and grab this and peel this away. And then I can just toss this sticks. And so you can see this fiber, I'll give you the side view. This is the fiber that we're extracting, and this is the wood. So we're discarding the pith, and we're the woody pith, and then we're keeping the fiber, which is the bark that's right here. And this is the inner bark because I scraped off the outer bark. So in order to do this again, my way that I've learned a long time ago is I hold it here, I have pressure, and hopefully you can see this, but I'm pulling down and I'm just keeping it at about a 45-degree angle. And with the pressure of my thumb, that allows me to come down 1 inch or 2, pulling with my left hand. And then I can break it right at that point again, and then watch what happens when I pull the wood away. I catch all those little bits of fiber that were going to get caught. And I only want to go down about 1 inch or 2 when I'm doing this, because if I go like this and come back, then I don't leave a lot of big pieces of fiber on there. So if I just come down 1 inch or 2 with that pressure, I come back, and every inch I back break, I let this happen, and it comes out really nicely. Let me show you if I don't do that. If I come down a really long ways, right, and then I crack the wood, you'll see all these long wingy pieces of fiber that actually are short ends that then are going to be harder to twist in. So if you see that difference, we don't want to do this. And then some people don't do the breaking first. They break here, and then they come down like this. But watch what happens is if I come down like this and I pull, then it's caught here, and then I have to pull these guys back. You see how many of those ends I have sticking out? So that's like that's more messy. Whereas if I'm coming in here and I'm pushing with my thumb, I get the pressure, I guide the release so the fiber comes off much more cleanly. I only go 1 inch, and I come back. Do you see how there aren't a bunch of taggy ends there? So I can come down, go about 1 inch with that support, and then I come back, and I'm keeping it. If there are taggy ends, they're much shorter. That was a little break. This is a weak spot in the fiber. When I was scraping it, I noticed that there was a place that an animal had eaten on it. So we're coming down, we're breaking back, and we're peeling it. I'm just going 1 inch or so, and then I'm breaking backwards. I'm going like that. I'm still in that area that was damaged by the animal. So I'm coming down like this. There is another way that my friends Benjamin and Kimberly, who are here, have shown me, which is really great, is where I come in like this, I crack, and then I pull the fiber here. And so instead of coming one like multi-directionally, do you see how I cracked and I'm pulling and I'm wrapping it around my hand, and then I can just toggle these guys off. And so sometimes that can be a really clean way of doing it as well. It's not as fast for me as coming down like this and breaking this way, but it's another way to do it. So I'm going to show you again. You come down, you just have a little bit, you toggle this around, you grab the fiber with your finger, and then you just pull that piece of wood off. And so if this is done well, you can extract it really cleanly. So I'm going to go back with this one, because it's the one that I am the most comfortable with, especially doing it around the computer like this. And so I come down with just 1 inch or so, I break backwards, come down and I break backwards, and you see how clean that fiber's coming off there? I'm getting very few broken fibers. And I continue doing that. Try not to go more than 1 inch if I can. And the key to doing this is having that pressure between your thumb and your finger. So if I try to do this and I'm like this, do you see that doesn't guide it off it well as well? So you want to be pushing with your thumb just enough, and then you pull with your other hand to get that off. And so now we've extracted the fiber off of half of the stick, and it's like this. And then we can go back and do it with the other half, which to show you the motion from this side, I'm going to do this half standing in front of you so that you can see how I'm holding it with my hands. So right here, yep, this camera's backwards, so you always walk the opposite way. So if anybody has any questions, like I said, put them in the comments. But right now what I'm doing is I'm holding this and I'm hitting the wood, the wood off, and then I'm peeling it back. And then I can set my fiber down. And so then this pressure with my thumb is the key thing. I'm trying to get in here so you can all see this really well. So I pull on the fiber and I slide down just an inch with the tension from my left hand. You see how the tension's happening there? Right at this point where they release, I don't move my hand because that's where I want to break the wood. So I crack the wood by pushing on it, and then I peel it back and I get those little pieces of fiber out of the way, and now I grab it all and I just pull with that pressure under my thumb, and then I crack it again and I peel it off. I pull, and you can do a hit too if you want, like a karate chop thing. So we go like this. I pull down, I break it. I'm showing a sideways view here. I pull down. Do you see that angle? That's all it is. And then I crack it and break it away. And when I break it away, I pull down, I crack it, and this point is I come in and I grab that broken piece of wood and I peel it back. Then I pull down, crack it again, peel it back. So it's working in short, repeated sections is how you would want to do this. I'm going to show you the other way, is that if I came down and I just moved down like about an inch, I break the wood, and then I grab it with my hand like this, and that gives me my two little toggly things. And again, thanks to Kimberly and Ben for showing me this technique, is I've got my toggles happening. It's hard to get the camera to see this way. Then I can come in and just work. I'm pulling the fiber tight around my finger, and then I just work these two off, and it is a pretty clean break on the fiber there. So either way, and again, this is that part the animal ate on the stick. I saw the damage when I was scraping it, so I was expecting it to break on me. But I come in, and that pressure with the thumb is the really important part on this technique. So I'm pulling down, cracking off. A car is driving by, so excuse the noise. I'm right out in front near my driveway. So I'm peeling this off. Somebody's saying something. Okay, so I'm putting that here. So now I'm left with the fiber. So this is one of the hanks. So this is half of one of those sticks of fiber right there. So if anybody was able to follow along with that, that's the extraction of the dogbane. And you pretty much do the exact same thing with milkweed.
We do have a couple of questions.
Okay, so what are our questions? Sarah Beth's going to read them to me.
So the most recent one was, does this process work for multiple wood types?
Yeah, I'm about to go into the other ones that this works for. What's another question?
Previously we had, is iris similar to daylily in terms of harvest and processing? We missed a few questions.
I'm going to do the iris as soon as I get done with this, so I'll talk about that in a second.
Back in the past also was, are you going to talk about gathering?
Oh, thanks, Ben, for the reminder. Yes, I will.
And then Angela asked blackberry vines and cherry bark.
Okay. All right, so the blackberry vines and cherry bark, I don't know if it has good fiber. I use the whole bark. I have never extracted cherry bark fiber. Blackberry vines, I would suggest that you go back into the discussion on the Echoes in Time group and watch Sharon's really awesome session from yesterday. It should still be up there. She talks extensively about blackberries and about fireweed and about what's the other one that she was doing that I'm forgetting right now? Nettles. So she gives a ton of information on those ones. So I would definitely go back and watch hers. Ben, thanks for the reminder on harvesting. So harvesting is dead and dormant in the fall with most of these things, but especially with the dogbane. And you go in and you're looking for the stem. The way the dogbane grows is it's got a really extensive root system, and it sends up a bunch of sticks right at the from the same sort of root core. It's like sort of a clump. And so you go in with clippers or with a knife and you're looking to harvest the dead stems, and you're looking for the ones that are from that year. So if you go into a patch that nobody's been harvesting, if you find a patch of dogbane that hasn't been harvested, you could find, especially in a dry environment, you could walk up to the patch, to the plant, and find like the previous 4 years worth of growth of sticks on that plant. And so you'll see that the ones from the previous years, like 2 years before, 3 years before, 4 years before, are going to be faded. They're going to be dry. You might even see the fiber sort of starting to disintegrate on the outside of them. Those ones have been weathered. Those ones aren't going to be the ones you're after. You're looking for the ones that have the reddest bark that look like they grew that year. And in a normal clump, it'll be like 3 or 4 sticks. And so you'll go in and you'll cut those ones. And then one of the things about harvesting that's a really important thing is the guidelines to doing it. I'm trying to find one here. That there's ethics on this. You know, usually the patches that grow tends to be pretty thick. Dogbane, once it gets established, tends to really like to grow. It likes, and it makes a dense patch, and it tends to sort of sometimes, you know, choke out other things or grow with a lot of population in there. This is a good one. But when it's growing, it's mostly stem. You can see right here. And then it's got the branches that happen. And then up in here, there'll sometimes be some seeds hanging. This one does not have seeds, but you'll see these branches. And so in general, you come up to the point where this one has, sometimes they don't have these big branches. You can break the branches off after you harvest it. But then at this point up here, you can either break them or cut them, but the fibers sometimes make it hard to break, so you can peel them off like this. So when you're going in, you're harvesting close to the base. You cut this cleanly. You don't want to be going in the spring of the following year. Sometimes you can still find sticks then, but you want to be careful because then the new little shoots coming up, you might be trampling on the shoots. So you really want to be in there when it's not actively growing young ones. So usually here in California, it's in the end of January, early February. I know that Ben and Kimberly are here and they're over in Yosemite, and they're in areas where there's heavy snow. You have to get in and harvest before it gets snowed on, before it gets buried by the snow. So they harvest much earlier than I usually do. So I usually harvest in the end of January, like I said, in February. But the ethics of harvesting is you go in and you harvest the dead stems, and you're not having to worry about the health of the plant from the stems you're taking, because everything that's above ground when you're harvesting in the winter is dead. So you're harvesting the dead ones. You can even, if you want to sort of help it out, you can cut even the ones that are old and lay them down on the ground to compost down and feed the plant again. And then you're taking away these stems. But one of the ethics that I was taught that I like to pass on is that this one is an example of what I wouldn't have wanted to do, except for what I do is I brought these home with all the little branchlets attached so that I could show people. But also what I do is when I'm processing them, I keep these in a bag, and then I will take these back to the patch so that they can compost and feed the patch more. Because especially at these patches that we harvest in, you know, people are going every single year and taking a lot of this material away. And that's material that if we weren't going in there and harvesting, that the plant would then, that it would be composting back and feeding the patch. So the idea is that when you're there harvesting, you sit down, you take the time to trim off any little things that you're not going to use, and you return them to the ground so that they can feed and better feed the patch. So you only take what you need to do. And I also like to do it is as I'm processing these sticks, I keep all of those little pieces that I broke off, which are, you know, all of these little pieces. I try to put them into a bag and keep them as I'm processing. And I take them all back to the patch that I harvested them from, and I spread them around the patch so that I'm feeding it. So I'm trying to take on a consistent basis, because I harvest at this patch every single year regularly. I'm trying to take as little as I possibly can so that the patch can stay in good shape. Basically, we're trying to maintain it, we're trying to steward it, we're trying to give it as much food as we possibly can. So this is an example of the dogbane. And are there any questions?
Yeah, there's a question. Deborah Christensen says, would fennel stalks or Indian tobacco work, or should I try one stalk to check?
That I do not know either of those plants. I haven't tried them. Try it, you know, and if they work. Fennel, I think I believe it does have fiber, and it's going to be much more like a green fiber processing thing that Sharon talked a lot about. And I should just say it right now so people know, if you're doing a green processing thing like with thistle stems or with which are weaker fibers. They can work as sort of more an entity. It's like a strip of the bark. You're not extracting, you don't scrape off the outer bark, so, or you can, you peel it off, but you're not trying to get rid of all the glues or anything like that. Those guys tend to be, and Sharon talks about it, is you don't wait as long as possible. What happens with them is they tend to have stronger bark up until the time they're starting to flower and starting to seed and starting to fruit. And then something about, my theory is that something about the fruiting process or something takes that energy away from the bark. So if you wait until they get too old, you're going to go in there and you're not going to have very strong bark. But if you're harvesting those green things earlier, then you might be able to extract a nice green with, or a nice green strip of the bark, and it might be strong enough to twist into something. So definitely, if you think something might work, the way people figured this out in the old days was going up to sticks and breaking them. If there's a strong bark, then you're like, oh, whoa, there's something here I'm going to work with. And that's what we can do whenever we're trying to figure out if something is a good fiber plant. But don't discard something just because at the time of year you tried it, it wasn't strong. Try it a couple different times of year. Like my thistles that I was harvesting this year, I got a bunch of really great bark off of my thistle plants in the spring before they went to flower, and it's really nice fiber, and I was really excited about it. And I harvested, maybe like 5 or 10 stalks worth or something like that. And then I thought, oh, I'm going to check them out and see if they're going to get any stronger as they go. And I waited until they fully went into flower and now we're done flowering, and the fiber is completely weak. It got too brittle, it got too coarse, and it's non-extractable now. So there is, with these greener things that you harvest more in the green state of the stem bast fibers that you're using in a more of a whole entity, you do want to harvest them earlier in the year. And Sharon talked a lot about that in her video, which was really good. Were there other questions?
No.
Okay, so I'm going to get to the multiple wood types in just a minute. Or actually, I should talk about that now before I move on to this. We've got 25 minutes left, so I think we're doing pretty good. So with the extraction, like I just showed you, the ones that it works for, the way that you process the stem bast fibers, cutting is pretty similar with all of them, but like I said, you choose whether to cut them in the starting from just before the plant's flowering to the plant being totally dead and dormant. You choose that window depending on the plant and the quality of fiber you're after. Then the way that you're going to process it is going to change. It's going to be different depending on if it is a perennial or if it's an annual. So the ones that are the two domesticated fibers that have spread all around the world are hemp, true hemp cannabis, and true flax, which is Linum usitatissimum. So those are the two, and both of those are annuals. And so those are the most widespread fibers that are processed all around the world. And since they're annuals, they die in the field, or if they're cut in the field right before they flower for a really fine fiber, you are harvesting them with all their lignins and with all their glues and with all the stuff intact, just like the tree bast fibers and just like the leaf fibers. And for that reason, once you extract the fiber from the stick, you have to, or before you extract the fiber from the stick, depending on what you need to do, you need to do something to break down those glues, just like you needed to do with the other ones. So the ways that people do that is they do a thing called field retting. So you can just cut the stems right when you want them at whatever point. You leave them in the field, and then you let the dew be on them for so many number of days, and you go out and check, and there's an art form to figuring out when they're done. And then you bring them in and you extract the wood and you do the cracking off and you break and you do what I was showing earlier in a different technique depending on the plant you're using. Or you take them out of the field fresh from having harvested them, you extract the fiber like we just did, and then you take those bundles of fiber just like you would take the bundles of the inner bark of a tree, and then you ret them by soaking them, or you do some sort of process in order to break down those lignins. And so that's you have to do some sort of a retting process. With the dogbane and with the milkweed, especially, and I believe the nettles do this to a certain degree, but I'm not so sure if they totally do it. But the dogbane definitely does it. Since it's perennial and it's got this big root going down, if you let it go dead and dormant, which is one of those reasons that we don't harvest it earlier in the year when the saps are there and when it's just gone to flower, if you let it go dead and dormant, the plant itself self-rets itself. It pulls all the lignins down, because those lignins, that are gluing all the fibers together are also what the plant is wanting to store for energy to send the next year's growth up the next year. So if you can wait long enough for it to go completely dead and dormant in the winter, that's one of the reasons in my area of coastal California and Mendocino County that I let it go as far as I can, like depending on how wet the year is. But my favorite time is if it's a fairly dry winter. If I can wait until January, then I know it's all the way dead and dormant. It's pulled all those lignins down. Then I do not have to do any sort of a retting process. And that's why you know that's why I can just do the scraping. And as soon as I've scraped, there's been no retting, nothing has happened. And this fiber was self-retted by the plant, and it is just ready to twist. It's beautiful, it's soft. I've scraped the bark off, and I don't have to hardly do anything in order to make this just go. I can buff it up and make it a little cleaner, but if you can see that, it's just ready. It's beautiful. It's ready to go. If I don't take the bark off first, or if it was hemp where it wasn't retted, or if I harvested this earlier, I'm going to show you the difference on this stick right here. And is there a question in there?
Yeah, there's one from Ben.
Okay.
He says, how about tule for rope and such?
Okay, yes, I will get to that, Ben. Hopefully I'll have time to do that. So this is what I did, is I just took the stem, and this is a bark, the dogbane, that has not been scraped. So this has the outer bark on it. And this is giving an example. It's not exactly the same as what happens when something is unretted, like if it was hemp that was unretted, or if I'd harvested this earlier when all the lignins were attached, but it is somewhat similar, so it shows what's going on. So I'm cracking the stem out. Like I said, this is a piece that I have not scraped the bark off, so there's a very thick layer of outer bark on this. And this is just a really good visual on what happens. And I come into the middle and I split it out. And so when I go to crack this off, it's the same thing. I peel it in, I pull it down, and I crack back like this. And then I pull down, and I crack back, pull down. And do you see that? The pressure with my thumb is super important. And again, I'm saving all the stems that I'm cracking off so I can return them to the patch, so I can help feed the patch. One thing about that I should say is I'm very careful to only return them to the patch they came from. You know, I don't know of any illnesses or disease, but if I had any suspicion that a patch might have some sort of illness, I wouldn't want to return the parts to a different patch. You know, I try to keep it where I'm giving it the same of what it grew. That tends to be pretty easy because usually all my dogbane comes from the same place. But, you know, I have been getting some from different places in recent years, and I'm trying to keep them separate. And you know, one of my patches comes from far away that my friends Ben and Kimberly give me, and I can't go back and give that back. So I'd compost those ones in my own garden. So here, if you look at this, there's this dark bark on there. Hopefully the light is good enough that people can see. And I'm going to come in here and I'm going to shake this a little bit, and you can see how the bark comes off.